Okay, these are some problems from the Chapter 6 review and just some antiderivatives or integration here to deal with. Okay, and number one, we have these are definite integrals, so we're going to integrate from 0 to pi over 3 of secant squared d theta, secant squared theta d theta, and that's pretty easy because that's just easy to take the antiderivative of that, which is the tangent. The derivative of tangent is secant squared, so we're all set. Evaluate from 0 to pi over 3. We're going to use, again, our fundamental theorem of calculus, and this would be f of b minus f of a. F of b minus f of a, so you can see that. That's what we got. Okay. And f of b will be the tangent of pi over 3 minus the tangent of 0. The tangent of pi over 3 is the square root of 3. Tangent of 0 is 0, so we just have the square root of 3. Okay, number 2, this is pretty easy. Also, we could just write this as x, and this could be x to the negative 2. So take the antiderivative of this just by using our power rule. Add 1 divided by, so add 1 to 1, we get 2 divided by 2. And like I said, I just move this up to the top. And then I can add 1 to that, which is negative 1 divided by negative 1. And that ends up being, and I'm going to evaluate that from 1 to 2 using the fundamental theorem of calculus. And we have to simplify this a little bit inside here just because I got a negative. So I wrote it like this. It would be easier to evaluate x squared over 2. And this is going to be negative. This negative sign goes there. It's going to be 1 over x, and I'm evaluating this from 1 to 2. Now, make sure you go through these. Make sure you try these on your own, all right? Just don't copy them down mindlessly because that's not going to help. And, you'll find that out on the quizzes. You need to know what you're doing. So, again, what we have here now is I'm going to evaluate this binomial, and this evaluated at 2 will be f of b minus, and this will be the f of a. In other words, this is my A, this is my B, and this is my A. F of B minus F of A from A to B. All right. That's where this negative sign comes from. We've also got negative signs in here, so be careful when you substitute and check your arithmetic. All right. See if you can do these without making any errors on your own, and then check them. All right. So when I put this in, 2 squared over 2 minus 1 over 2, that's the one part at 2. I'm going to put it 1 squared over 2 minus 1 over 1. Well, 2 squared is 4. 4 divided by 2 is 2 minus 1 half. And then 1 squared is 1, so it's 1 half minus 1. And again, there's the negative from the f of b minus f of a. Well, 2 minus 1 half is 1 and 1 half. And then this 1 half minus 1 is negative 1 half, but a negative times a negative is positive. So this ends up being 1 and 1 half plus 1 half, which is 2. Okay. Okay, so nothing, just straightforward anti-differentiation and fundamental theorem of calculus to evaluate that, or sometimes called the integral evaluation theorem. Okay, we've got the integral of from 0 to 1 of 36 dx over 2x plus 1 to the third. And if I think of this as u to the n, my u would be in here. The derivative of 2x plus 1 is just 2, and I can fix a 2. I can't fabricate a variable, but I can fix a 2. So I'm going to approach it like that, and I'll try to get this up to make it a u to the n. Not 1 over u to the n, but u to the n. I took the 36 and put it out in front, and I let u be 2x plus 1. So now I've got the integral. Like I said, I took the 36 out. So if I let u be 2x plus 1, this is going to be u to the negative 3 dx. But I have to have du. And I'm going to have to change my limits of integration, so I'm not going to write anything here until I really get squared away here. So the derivative of, well, u is equal to 2x plus 1, so the derivative would be du, which equals 2 dx. And then I divide by 2, and I get a match over here because I got my dx and my dx, so I want to match those up. So instead of writing dx, I write du over 2. I can bring the 2 out as 1 half, but 2 goes into 36 18 times, so I can fix that a little bit. And then when I change my limits, this is going to be 2x plus 1, so this will be 1. So 2 times 1 plus 1 is 3. And 2 times 0 plus 1 is 1. So those are my new limits. This is my derivative all ready to go. take a look at that and make sure it all makes sense. Then I've got the 18 in front. And I can take the antiderivative, so I would add 1, which would make that -2, and divide by the -2. And still, that's going from 1 to 3. So I'm going to dock this. I'm going to fix this a little bit, and just put the negative in front, and I put the u on the bottom. So I have u squared, because I can't evaluate that. I can't evaluate u to the -2. I don't know what the heck that is, but I know 1 over u squared is. I know what u squared is. So again, we have the 18 in front of the whole shebang. And evaluating this at 3 will be the f of b minus the f of a. That's the f of a. Now I have a minus sign, a negative sign for my f of b minus f of a, and then I've got a negative sign in here, so be careful with all these double negatives. And here I put negative 1 over 2 times, and what's u, when it's b, I'm sorry, when it's b, it's going to be 3 squared, minus, and then negative 1 over 2 times 1 squared. Let me just simplify this. Okay, we have the 18 out in front. 9 times 2 is 18, so I got negative 1 over 18, and then this is a negative times a negative is a positive, and 1 over 2. So if I make this all over a common denominator of 18, 1 over 2 is the same thing as 9 over 18. And 9 over 18 minus 1 over 18 is 8 over 18, so I've got 18 from here times 8 over 18, and that's just 8. Okay, so hopefully that all makes sense. Take a look at it. And again, you should try these on your own, and then if you don't get the answer in the book, you probably did something wrong, and this will show you probably where you made your mistake. Okay? All right, let's do number 4. And number 4 is the integral from -1 to 1 of 2x sine 1 minus x squared dx. All right. And then we might notice that the sign of the function is, well, we've got an x there, so I was going to say it's an odd function, so we might notice something about this. But let's go ahead and work it out. So I put the 2x in the back, so it looks like I've got sine of u du, because the derivative of 1 minus x squared is -2x. I got the x, that's all, that's important. I can fix everything else up. So I let u equal 1 minus x squared, so I put this in here. So I've got the integral, and I'm going to change my limits of integration, so I'll just sine of u times 2x dx. So I want to find out, get this to be du, so I take the derivative of this, so du equals -2x dx. And I've almost got a match here, you see. I need to match this with this. So I'd have to divide both sides by -1, so I got du over -1. And then when I change my limits, I've got 1, and then 1 minus 1 squared is 0. And then I have -1, but 1 minus -1 squared is also 0. I have this negative, I put this du over -1 just for completeness. In fact, this is out, but I end up with the integral from 0 to 0 of the sine of u du. Doesn't matter anymore. The integral from 0 to 0 is 0. That's pretty much a done deal there. Okay. And let's take a look at one more, number 5. The integral from 0 to pi of 5 sine to the 3/2 x cosine x dx. Now again, we can think of this. This is the abbreviated form. We don't really like this when we're taking antiderivatives, because it doesn't allow us to appreciate the u to the n du. And I know the derivative of the sine is a cosine, so I'll rewrite it in this factored form, this parentheses form, which makes it look like u to the n sine of x to some power times this, which is the derivative of sine of x. I just put the 5 out in front. So I'm going to let u be sine of x. I'm going to go for u to the n du, because I've got the derivative of sine, which is cosine. So all set up. So let u equal the sine of x. So I'll rewrite it like this. 5 u to the 3/2 cosine x dx, but I got to change this to du. So if I take the derivative of the sine and the derivative of u, I get du equals cosine x dx. That's the derivative. So it fits in. I've got it like a perfect match right there. It fits in perfect. Okay. So I'm ready to rumble here, ready to go. So right there, nice perfect match from there to there, you see. All right. I should actually go over here. So that becomes du. So instead of writing this, I write du. Okay? And I changed my limits, so this is going to be pi over 2, so this will be the sine of pi over 2, and this is 0 sine of 0. And that's going to end up being sine of pi over 2 is 1, and this is 0. And I can go ahead and evaluate it right over here. There you go. From 0 to 1. And this is a 5 out in front, so I got 5. And the nice thing about the 0 is this whole factor will go away. I wrote it out here, but you could just zap it. Okay, so 2/5, 1 to the 5 halves minus 2/5, 0 to the 5 halves. That goes to 0. That's just 1, so that's 2/5. So 5 times 2/5 is 2. And you're done. Okay? So not too bad. What kind of fast? You may want to slow them down. Study these up. Make sure you thoroughly understand these. These should be well within your capabilities. All right? Well within your capabilities. So please check these over. Spend a little time with them.